Let's look at our first example. We have the function fx equals x squared minus 4x plus 3. Now what will happen is we will actually input an x value and substitute it in here every time we have x and then get an output. So let's look at the first one. Well, what if our x value is -1? Then instead of f of x, we're going to have f of -1, and that's going to equal -1 all squared. Notice it's all the x, the whole -1 that's squared, minus 4 times -1 plus the 3. Now I evaluate this. -1 all squared gives me 1. -4 times -1 plus 3, and we get when the function of -1 is actually equal to 8. Okay, let's look at the second example. When we have the function and we have an x value of √2. So instead of f of x, we're having f of √2, and we sub it in. √2 all squared minus 4 times √2 plus 3. Now let's simplify this. √2 all squared is simply 2 minus 4 √2. We can't do anything with that. That becomes a third plus 3. And now we need to collect like terms. So we actually have 2 plus 3. We get 5 minus 4 √2. And that's when the function is f of √2, we get 5 minus 4 √2. Okay, now let's look at the last one here. When we have f of 3/4, we're going to sub in 3/4 for x, and so we get 3/4 squared minus 4 times 3/4 plus 3. 3/4 all squared gives us 3 squared, 4 squared. 3 squared's 9, 4 squared 16. Minus, our 4's cancel, so we're left with 3 plus 3, -3 plus 3 cancel out, and we get 9/16. Can't be simplified, so when we have a function of 3/4, we actually get 9/16.